Hello everyone, I'm back again with yet another video on the topic analysis of different techniques in MRI and CT scan imaging. It is from DSP, Digital Signal Processing. As you all know, my name is Said Irfan and I am pursuing my electronics and engineering. Hello everyone, welcome back to your own channel Capsulated Breakthrough. I am back again yet another video with analysis of different techniques in MRI and CT scan imaging. This is a topic from DSP, Digital Signal Processing. As you all know, my name is Sadir Khan and I am pursuing Electronics and Communication Engineering in Sri Venkateshwara College of Engineering. Without wasting much time, let's start the video. Yes. So what we have to understand what is MRI technology. How does the MRI technology works? MRI utilizes magnetic fields and radio waves to create detailed images of organs and tissues. Right. So now we are the human bodies. If something is wrong in our internal body, how would we get to know? If there's some minor cracks, if there's some minor issues, some minor tears in our tissues, how would you get to know? These all things is possible through the MRI technology. For example, you have to see something in your brain, something's wrong with the brain. So there are some minor cracks, so there's some minor tissue tears, tissue pulls. How will you get to know? That is done by MRI scanning. Now, so what are the differences between CT scan and how this CT scan play a major role in DSP? What role of DSP is involved in this CT scanning and the image interpretation? CT scan employ X-ray to generate cross-sectional images, right? Providing comprehensive view of the body. So basically, CT scan gives us a comprehensive view of the body by providing X-ray images, right? It takes an X-ray of different places of the particular focused tissue and gives us an exact image of that. What is the role of DSP in doing this? DSP, digital signal processing, is comprehensive in processing raw data from MRI and CT scanning, interpretable images. Right? What is the image interpretation? The processed image are vital for the accurate diagnosis of the effective treatment planning. Okay. Now next, that is the signal acquisition and pre-processing. The signal acquisition and pre-processing. The first step is signal acquisition, then noise filtering, then image quality enhancement, signal normalization, critical processing steps. So before an audio reaches you to your ears, these many steps are involved in filtering out the noise, making the audio clean and making the audio wild so that anyone can hears that can be confidently hearing. What is reconstruction techniques? What are the techniques in which images can be reconstructed? So basically, there are many techniques. Let us go one by one. First is image reconstruction process. And how does this happen? The transformation processed signals into visual images and clinical use. So basically, anything, for example, let's take a system from one mobile phone to another mobile phone. If you're sending an image, that image goes as a, what do you call it? The image goes as a signal. Then these signals are reconstructed to form a image or a visual or a video or anything. But when they are transmitted, when they are traveling, these are traveled as signals only, not like your exact image is traveling there. No, these are broken down into signal codes. The signal codes are then these are reformed and reconstructed back to the own original video or audio form or image form. Okay, the next is Fourier transforms, a mathematical method used to convert signals from time to frequency domain, essential for image clarity. That is, images are being transformed through Fourier transform. Then, filtered back projections, FBP, a technique used in CT scans to enhance the reconstruct image from projection data. What is inverse FFT? Used in MRI, this method converts frequency domain back into the special domain for imaging. Now, DSP algorithms. What are the DSP algorithms? DSP, digital signal processing algorithms, are crucial for transforming complex signals into interpretable images. Okay, so what basically is the role of DSP in the noise reduction? How does DSP play a major role in reducing the noise? That is very important for us to understand, right? Exactly. So importance of noise reduction. Noise reduction, why? Why is noise reduction very important? It's a very basic answer that noise reduction is essential for improving the clarity and quality of the medical images, which is a vital for accurate diagnosis. If noises interpret the signal images, then we will not get an accurate image. For example, if you want an accurate image of what's happening in your kidney or in pancreas, if noise interferes the signal, those accuracy, the proper accuracy of the images generated by the CT scan or the MRI scan will not be at most with the accuracy. Next, Gaussian filtering, a common DSP technique that smoothens the images by reducing noise while preserving edges, enhancing overall image qualities. Moving on to the next, that is wavelet transforms. This technique decomposes images into different frequency components, allowing for effective noise reduction without losing important details. The next one is adaptive filtering, an advanced filtering method that adjusts its parameters based on the characteristics. Okay, if the demand of the image characteristics is different, then this adjusts itself, and based on that, it comes on differently. The last is minimizing artifacts. So what artifacts are we minimizing here? DSP techniques not only reduce noise but also minimize artifacts that can obscure diagnostic information, ensuring reliable imaging results. So, irrespective of noise, if there are any artifacts that are being as an obstacle to the image transformation, that can reduce it, it can minimize it. I hope you understood the role of noise in noise reduction in the DSP. Next, enhancing the image contrast and resolution. Now we know what role this noise plays in the DSP or DSP plays in noise reduction. Now we'll have to see utilizing DSP techniques for improving the medical imaging interpretation. Okay, improved image contrast. DSP enhances the visibility of critical features in medical images through various techniques, so that the images are being well clarity with good clarity, that so that it can be examined by doctors, by physiotherapists or those who specified, so that it can be clearly so that they can read it. Then enhance spatial resolution. Higher spatial resolution allows for better detection of subtle pathological changes. Edge enhancement techniques. So what are the edge enhancement techniques? What basically does it mean by edge enhancement technique? Is helping to highlighting important features for clear interpretation. The next is contrast stretching methods and clinical interpretation aid have similar working. In contrast stretching methods, the burden of the range is intensity levels of an image. In the critical interpretation aid, enhanced images make it easier for the clinical to accurately interpret the medical images. Now, what are the applications of DSP in medical imaging? Right? DSP techniques improve the clarity and accuracy of an image in cardiovascular studies. And then one is cardiovascular imaging, then tumor detection. In case if you have any tumor, then MRI, that is the medical imaging, works very well to detect tumors, then enhance decision making. Now, trends in DSP in medical imaging. I would not be reading the trends. I would just be telling the names of the trends, because trends are, these are futuristic trends that humans are expected to achieve in medical imaging with respect to DSP. That is advancement in AI. See, AI in today's generation is in everywhere. So even in this, advancement of AI is quite required. Then medical learning integration, automation of process, improved image accuracy, personalized medical care. Improved image accuracy is one of the major thing where humans are working rigorously with very much high speed, so that they can end up getting in very good results. And automation process of MRI scanning is also one of the major things they've been focusing on. So that is the thing. That is it for today's video. It was a quite short video. I only explained you about the MRI scanning and the basic roles of DSP involved in MRI scanning. For more such short videos within 6 minutes time, you can subscribe my channel. Until next time, see you. Sayonara.